Hello, students. We are jumping into the MCs for 7.1. You have 5, 7, and then, wow, like I did it again, 13 to 17, and then 18 to 20. So basically 13 to 20. All right, let's see here, though. So as you look through these, you will see some historical notation. I'm not asking you to write things in historical notation. I think that's great for the past, but we are moving beyond the past. So when I ask you to do things, we'll do 5 and 7. Okay, 5. Explain why you think a sign on a copy machine reading, and then it has a little saying, this much per copy is put up by mistake. Okay. I worked at McDonald's, and so for a number of years, and I got to tell you, this thing is very, very common. People think that's very clear, and I need you to tell me why there's a mistake there. What's the issue? And number 7, explain why in theorem 7.1 the rational number must be in simplest form before examining the denominator. So why? It says it has to be in simplest form. Okay. It has to be a fraction, a rational number in simplest form. Why? Why can't we just examine the denominator and make our determination? If you watch the prior video, you'll have a pretty good reason why, but if not, you may want to jump back and watch near the end of that video. And then 13 through 20. Reading a decimal part is important skill. Reading the decimal part. 403 should be read as 403, not 403. Oh, yeah. There are still some of you in class I know who struggle with this because we're not saying 403 and 5/10. We use the word and once as our demarcation line between whole numbers and fractional numbers. Okay, explain how this shows why children should be taught to say whole numbers correctly. Okay, so take an example there. Some of you, I know, maybe you got used to saying it a particular way. That doesn't mean that it's the proper way to say it, as you know. And the reason for that is that we do not want the and to become utilized for all additions, honestly. So is there anything wrong with saying that? Remember, if you write this in expanded form, isn't this 400 plus 3 plus 0.5? We write it this way. So 403 and 5/10. So technically, yes, it could be read that way. But then what happens then is we run into issues when we write words and also when we say them. So what we want is we want the and to be that demarcation. So we would put these together and say 403. And then we put in our 5/10. Okay. All right. All right, that's 13. Let's move up a little bit here. Take a look. What else do we have here? Connecting math to the classroom. We get the students again. So here come the students. A student claimed that 0.304 is equal to 0.34 because 0 is nothing. 0 is nothing. How do you respond? Yeah. Well, hopefully you're not in that same boat, but hopefully you can explain to them why 0 may not always be nothing. All right. 0.86 is greater than 0.9 because 86 is greater than 9. Love it. These are not uncommon, by the way. These are from actual classrooms. They bring these in and put them into these books so you get ready for what students are actually going to be saying. Let's see here. Stella says add a 0 at the end of a whole number to make it 10 times greater. So adding a 0 at the end of a decimal would make it 10 times greater. Okay. So think about that, right? If you had the number 3 and you put a 0 at the end, it's 10 times bigger. So if we did this and put a 0 at the end, then it's also 10 times bigger. How do you respond to Stella? Okay. D'Angelo sees a symmetry in the decimal place values and wonder why there is no once, right? We have ones, tens, hundreds. Then over here, tenths, hundreds. Like, why isn't there a once place value? Create an explanation. Tell D'Angelo. All right. And Maria writes 100th as this. Okay. How is her reasoning incorrect? What was she thinking? Right? She clearly has an idea. She's written something that involves 100. So wonder if maybe she's thinking something like that, but you do it. Tell Maria. What are you going to do to help Maria understand what she's mixing up or missing? All right, students in the seventh grade classroom are asked what number is halfway between 1.3 and 1.4. Common explanations were 1.3 and a half, 1.3.5, and 1.35. Explain any misconceptions the students might have. Interesting. Let's see here. And Alan knows 4 is less than 5, but 1/4 is greater than 1/5. So therefore, 0.4 must be greater than 0.5 because these in his mind are fractional numbers. And the fractional number, the larger the value, the smaller the fraction. What is the mistake he is making? And how can you assist Alan? And let's see. I think that might be it, right? Yeah, just through 20. Okay. Well, that's 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 all she wrote for this one. Chapter 7.1 is in the books. I'll move on to 7.2. I hope you do too, and I'll see you shortly. Off you go.